Good morning. Welcome, welcome. We got to get ready for the exam tomorrow. Not tomorrow. Tomorrow is Wednesday, isn't it? Not Thursday. Losing my grip on the days of the week. We got to get ready for your exam on Thursday, and we've got to go over kind of several things. We'll get into the topics here in a little bit. If you have questions about this, I just wanted to make sure that you knew that the topics list does get posted as an announcement. We'll talk about this in a bit. Let's talk about kind of what the format is and what to expect. If you go to the first unit, okay, down at the end it says 2A exam sample, because that's exactly what it is. I didn't want to make a new exam sample because this isn't really about like the level of difficulty or anything like that. It's more of a way to communicate to you the two kinds of problems you'll experience on an exam, and sort of the expectation of explaining what's going on in the problem, right? So in the context of 2A, this is a projectile motion problem, but you're going to have 6 problems that are like this, where you're given a question and you're asked to solve for one thing, okay? And then I expect some way of communicating to me, like, what you're doing. What equations are you using? What do you know? What are you doing? You don't have to follow like a specific problem-solving method, but I do expect you to be able to communicate to me and explain what you're doing. I read a lot of math and I read all physics, right? So I don't want you to get worried about, am I doing this in a way that Mr. Balogh can understand? But I do want you to just put everything you've got in your head on the page, right? Whatever it is. And if and when you think it's wrong, do yourself a favor and don't erase it. Just draw a line through it or put a big X through that work and then turn the page over. There's plenty of blank spot to work and all that kind of stuff, and keep going. I've been known to give credit if you thought you were doing it wrong and crossed it out and then did something else, and I see that your original attempt was more along the line. Maybe there's some credit to be given there, right? So my advice is don't destroy any evidence, right? Okay? You are not attempting to give me a perfect exam. I mean, obviously you want to answer all the questions correctly or something like that, right? But it's going to be messy. It's going to be all over the place, and I don't want you to stress and worry about some organizational technique and method of doing the exam. Just get down what's in your head, and we'll take care of the rest later. So there's a type of problem where you'll be doing like math and sort of these physics problems. And then there's the conceptual question. This is usually one on the exam. Your 4th unit exam might have more than one of these on it, but usually one. And again, I expect an explanation. This is possibly the easiest problem to miss, even though you get it right. The idea here is that if there's no explanation, and even if it's a correct answer, it's still wrong, because in my mind, and in really all STEM fields, it's not so much the answer, but how you got there that makes all the difference. So please make sure to explain the choice that you are making. And when the question comes up, Mr. Balogh, I don't know how to explain it because it's the only right answer, explain why the others are incorrect, right? I tend to be somewhat lenient in that, like, some people are like, well, I can only explain why 2 out of the 4 are incorrect, and then I'm just guessing on the last one. Well, then tell me that, right? There could be partial credit for explaining why a couple of those are incorrect statements, right? So again, get it all out on the page, right? As fast as you can, as much as you think, or more than you think is necessary. This front page right here is the front page that you'll see tomorrow, obviously with some changes. One of the things that my students seem to have the most difficulty in doing or remembering to do is to circle the lab time. on the front page. Before you put your name on there, circle whether you're in the 8 o'clock or 11:30 lab time. It'll say 11:30 on your exam. But yeah, that just helps me to sort them later to make sure I get them right back to the right people. There is this honor pledge, okay, and I'll put that up on the screen and have you write it into this blank spot at the bottom of the title page and sign it, right? And again, this is more of a conversation starter, right? It is an expectation that you do your own work and you don't get any authorized assistance. But in the event that there's a problem, or I perceive that there's a problem with you abiding by it, I want to use it as a conversation starter and not a club. More on that in the syllabus if you need to know. Okay, I think, so you can go on there, you can read the title page and you can see kind of the rules. For those of you who haven't had me before, you'll be putting all your bags and stuff up here on the front. And in your bag, you just need to make sure that you put all of your, like the only thing that should be at your table is something to write with, your summary sheet, your cheat sheet, and then a calculator, right? I'll provide the exam. You don't want me to have to wonder, right, whether or not something sneaky is going on. So devices off of you, smartwatches, AirPods, phones, that sort of thing. Water bottles, just put them all away. If you need to get up and take a drink, you're welcome to stand up and get a drink, right? But try not to mess with anybody around you. Let's see. You can go read all of that. Those of you that have had me before, what kind of advice could you give to somebody that hasn't had me before? Like in 2A, they had a different teacher. They didn't have Mr. Balogh. What's like is there anything you can tell them to help them? In other words, what am I missing? No advice? Just give up? I wondered that myself. It's no longer the train. It used to be in the other building. I could blame the train, but now I'll just blame the fog, I guess.
Oh, it still could be the train.
Yeah. I also think that some people aren't coming to campus because most of campus is closed.
This is the only class I had to.
Right, right. So good job being here. Yeah. Anything we could tell people that haven't had me before, like kind of what to expect? How did I do last semester on like the difficulty? Like did I hit that sort of medium level difficulty? Was the homework harder than the exams, or was it the other way around? The homework's harder than the exam, right? And some of you, I remember, tried to make the problems on the exam harder than they were, right? Thinking, oh my gosh, this is like a homework problem. I got to make it really super duper hard. And really, I was just asking you to do something fairly quick. So try to keep that. What did I do to you guys when you asked questions? You were sitting there in the exam, you asked a question. Did I come up and ridicule you? Yeah, no? Did I laugh at you in front of the entire class? No. Were some of you surprised at some of the answers I gave? Yeah? Okay, just ask, right? I'll try to clarify, and I know how to keep it fair for everybody, right? So if you're wondering something, not sure about something, not sure you're reading the question right, just ask me, right? What's the worst I'll say?
No.
I won't do that. I try not to say I can't do that, because I probably can. I just refuse to keep it fair for everybody. But if I think everybody needs to know something, I'll come up and I'll put it on the board, right? Whether it's a constant I forgot, or did I make, was it your class that I made the mistake in? I like had a typo on the exam and I had to edit no, that was 2B? Okay. I did that in 2B last semester, so maybe I'll do it in your class this semester. I make mistakes too, but I also know how to fix them, so mostly. What questions do you have that you need answered, like about the exam, how it's taken, maybe not necessarily physics stuff, but like the mechanics of it, that you need to know right now so that you can come in Thursday and be concentrating on the exam? Don't be afraid to ask. Yeah?
Blank sheet of paper with notes on both sides?
Yes, right? So your 8.5 by 11 sheet of paper, you can put whatever you want on both sides of the sheet. I will ask you to staple those to the back of your exams, but they will not be graded. They are something that I do after I'm done grading them. I take a look at them just to kind of get a snapshot of what you guys think is important. Because what you guys think is important, what I think is important, are usually two very different things. There's like extra pages on the exam if you need more space, more work. There's blank sides on the back that are there. If you need more pages, it's not a problem. I've got extra pages. We can just staple them on at the end. So don't panic about that. Anything else? You're so jaded from Physics 2A.
Will there be conversion factors?
Yeah, I'll put any conversion factors that you need on the exam. And not if, but when I forget, sometime this semester, just ask, right? Say, Mr. Balogh, I need this conversion factor. What's the one exception to that rule that I've told you guys? I won't give you conversions for something that I expect you to already know. Yeah, like the kilo, mega, giga, milli, nano, right? Those prefixes, right? So if you ask me on the exam, Mr. Balogh, what's a microcoulomb? You need to know that now, okay? So if you can't remember what a microcoulomb is, what the symbol is, or that it means 10 to the minus 6, where are you going to put that? On your cheat sheet, right? So yeah, I won't give you, because I don't actually consider those conversion factors. They can be used as such, but I don't consider those conversion factors. It's not like we're going from one unit system to another unit system or something. It's just a shift in where you're putting a decimal point. So those are important to know in any STEM field. Trying to think if there's anything I've forgotten to tell you. Probably. All right. Let's talk. I kind of don't want to mention this, but I'm going to mention it anyway. In the syllabus, and I said this at the beginning of the semester, but I'll just kind of remind you, because unfortunately, students worry about this more than they need to in preparation for an exam. But there is a sort of rubric, right, in the syllabus for like how I score the exam questions. Because the question comes up, is there partial credit, right? So what I did, there we go. What I did, boy, this really doesn't like to do this correctly. What I did was here's the problem with me and rubrics. 0 to me is fairly clear. There's been a major problem, right, with the problem. I usually write down a 0 as like a -2, but you're getting 0 points for the problem. And there's some fundamental flaw. There's a big mistake in the physics, right? A 2 means good job. Like you did what the problem asked. You provided the correct units. Your math is sound. Your numerical answer is correct. But between those two sorts of extremes, there is a fuzzy 1 point land, okay? And this 1 point, it totally depends on two things. One, the actual question topic. So different topics have different sort of like nuances for what constitutes like a partial credit answer. But I think the other thing this depends on is the subjective call that I have to make, right? Did you get the physics? Like, are you understanding the physics? Are you showing me you understood the physics? And then there's just small errors that are more than like stupid math mistakes, okay? Which again is a judgment call on my part, but also you communicating to me what's going on in the problem, right? There's this sort of back and forth there. And so what I'm always pleading for students to do is give me as many excuses as you can for me to give you credit for something, right? Even if, like, I say it always, right? Strong and wrong, right? Okay? Don't feel like you are going to condemn yourself by putting down too much information. Try to show me what's in your brain so I can make a judgment call there. So I don't really say that I give partial credit because it's not like I give a 1 if you got halfway, right? You kind of have to get the physics correct still, but then there's some other problem somewhere that I feel justifies not giving you full credit for the question. Many of you last semester in 2A would get a problem marked incorrect, and then it would say -0. And do you remember what that meant? It meant that there was something wrong. I'm giving you 2 points for the problem, but there's still something wrong. And that something wrong, my intuition or my guess or my feeling is that it's somewhere in a stupid math error, like an arithmetic error, or not getting the parentheses right in your calculator error or something like that, right? It's not fundamental to your mathematics and it's not fundamental to the physics, but I also don't have the time and I'm too lazy to actually dig in and see where the problem is. So as far as I'm concerned, you've set this up correctly, you're showing me correct physics, you're doing good math, your number, my number differ. I consider it's an incorrect answer, but it's also, I'm not taking any points away. So to me, that's more like kind of what partial credit is. So you can of course have a different opinion. And then we'll talk about the exam autopsy next week. So, everybody always asks, when am I going to know my grade? And the answer is at the exam autopsy. You're going to come in and that's where you'll first see your grade, and you will be among friends where we can console you, right? Make sure you don't jump off the 3rd floor. All right. Topics. Any questions about these topics specifically? Like, what do I mean by what I said there, or anything else? This is your chance now. This is what I consider like the review part, right? Where you ask questions, you tell me what you want me to do to help you figure out what's going on. Guys are so lively today. What happened? Too early? Too foggy? Too many drawings yesterday in lab? Should have given you a horrible mathematical lab to get your brains up to speed. Where do you think you're going to run into vectors? So, are you going to see vectors in the capacitor problem? No. Will you see vectors in Coulomb's law? Yeah, right, because Coulomb's law is dealing with forces. So there's going to be vectors there. DC circuit reduction, any vectors there? What does that even mean, DC circuit reduction? Simplifying a circuit, a series and parallel connections down to one equivalent resistor, and then maybe having to work backwards a little bit, although, spoiler alert, you don't have to work backwards on this one. Electric field, the point charges, are there vectors there? Is the electric field a vector? Yeah. Electric potential and electric field conceptual. I mean, conceptually, there's direction associated with some of these things, right? We did a whole lab yesterday on that, right? So, but like not actually having to do the mathematics of vectors there. Electric potential of point charges, are there vectors there? When you're calculating voltage? Nope. And what about electrical power? Nope. Right? So what does that suggest to your mind as a possible strategy for the order in which you do the problems on the exam on Thursday? Which ones do you think you might want to tackle first? The ones without vectors? Why? Vectors probably going to take longer, right? Especially if you have to find components of things, right? And my advice, specifically on my exams, is don't do any of the problems in order. None of the problems depend on any other problem on the exam. So you can do them in any order you want. They are all the same value. So a problem that could be the most difficult problem on the exam is the same 2 points as an easy problem on the exam. So my advice is go through the exam and identify, like in the first 2 or 3 minutes, just identify all of the problems that you think you can do quickly and do those so that they're out of the way. Worst thing you can do is start on problem 1, get into it, look up and realize that 35 minutes has gone by and you haven't done any of the other problems on the exam, right? So you've got to pace yourself. You've got to hit that average of 10 minutes per problem. And the way you're going to do that is by jumping around, right? What happens if you're 2 or 3 minutes into a problem and you're getting nowhere with it? What do? Move on. Skip, go to another problem. Avoid catastrophizing, right? Oh my gosh, I didn't get this one, I'm dead. Oh my gosh, I can't get the next one, I'm dead. Oh gosh, the third one, I can't do it, I'm dead. Right? Just keep plowing through, right? Just keep moving through. Even if all 7 you're like, I can't do this one. At some point your brain's going to start, it's going to be working in the background on these questions, right? And you'll be working in one problem, not getting anywhere, when all of a sudden you'll realize, oh, that's right, I got to do right, and you'll skip back to the other problem. And I guess what I'm trying to say is be a little bit attention deficit here, right? And hop around. Let your brain be flexible. Let it know all the problems you're up against so it can kind of start categorizing in your subconscious and bring that to the forebrain when you need it. I always avoided vector problems till the end. That worked up until the point where I just had an exam that was nothing but vectors on it. And then I still remember that day. It was a bad day.
I think I did miss that vector problem on chapter 18, number 8.
Do you want to take a look at it?
Yeah.
Let's take a look at it. You're going to have to give me a moment. Because I got to pull it into something I can actually write on. We'll just do this. You said it was number 8?
I think so. I'm pretty sure.
Well, this is a flux problem. You don't have to worry about that.
It's not that. It should have a triangle.
That one?
Yes.
This one right here, right? Okay. All right. Has anybody figured out a better way to like copy and paste into your note problem? Into your note program, rather? Is this kind of how everybody still does it? Okay. Nope. You guys are not in 4A or 2A. If anybody has a better method than what I just did, let me know. Okay. Okay. There's a triangle, there's words, there's charges, and there's like a distance. So sometimes when I'm scared and I can't think and I haven't looked at this problem in a while and now everybody in the room's looking at me expecting like I know what I'm doing, I go for the low-hanging fruit. Okay? Like what's something I can do right away without even like barely reading the problem? One of those things is to convert these like any number they give me, right? Okay? This is going to be 3 times 10 to the minus 6 coulombs, isn't it? And so I just do that, right? 2.5 centimeters. So I'm going to write that as 0.025 meters. And I'm going to hope that I did that conversion correctly. Because if I didn't, I should give up and become an English major or something, right? Okay. So I only see the two numbers, and I put them into their metric standard units. I might need that later. And now I've actually got to read the problem and figure out what they're asking. So I'm going to... Let's see, do I have a highlighter that even works here? Calculate, okay, so magnitude of the net force is what they're asking me, right? Okay, and they want that on each. So I've got to find this 3 times, don't I? Okay. No, knowing what I know, it's just going to be a lot of work. So... how am I going to, let's just start with the force on A. Down there in the corner, right? Here's my A. What do I need to know? The force on A is going to be due to the force, oh shoot, how does your book do it? Is it the force on the thing because of the thing? Like what are the is that what it is? FA because of B, and then force A because of C. Like there's 2 things going in there, right? So let's see, what's the force on A because of B? I can find the magnitude of that force. That's going to be K, QA, QB, and remember those are all like absolute values, right? Divided by the distance squared. So that's 9 times 10 to the 9. And then 3 times 10 to the minus 6 times 3 times 10 to the minus 6, all divided by 0.25. And squared. Thank you. See? I'm glad you guys are watching. Teaching is like taking an exam every day. And being graded by 60 people. But the good news is that in the end I always get it right because you guys tell me what to do. All right. No, I won't do the same thing for you on your exam tomorrow. Anybody have this number? I've got 2 of those, don't I? So square it. And then 0.25. I got 1 point, I'm going to call it 3 newtons, right? So that's a magnitude, isn't it? Okay, it's just the strength of the force that charge B exerts on charge A. But a magnitude isn't enough. I need to know like the vector directions and all these things that are happening, right? The good news, right, is that when I go to calculate force on A because of C, does anything change? Like just in the magnitude calculation. Does K change? Yeah. I think I put in 0.025 in my calculator. Maybe I didn't. I bet you I didn't. No. Mine doesn't undo. Anybody, did you get a different number, Alex?
I keep putting in the calculator wrong.
Did you get 130? Did anybody do this? It's 130? So you guys need to correct me. Because I didn't put in the 0.0. 0.0 in the denominator, you square. Yeah, so we'd have to move the decimal point 2 spaces. Yeah, okay. All right, so 130 newtons. Now, what about AC? Does the K change? Does the charge on A change? Does the charge on C change? All of these charges are the same magnitude charge, aren't they? So none of these, does the distance change? No. So this, this actually is equal to exactly the same thing, right? However, what does change is that, so what direction is the force on A because of B? Opposites attract. So what's the direction of attraction? Up towards B, isn't it? So this is 130 newtons this way, isn't it? Okay. And then what about A because of C? Yeah, it's attraction again, so it goes towards it, right? And we get 130 newtons right there. Okay. So now we have to add these together, don't we? Okay. So even though I know that the magnitudes are the same, I got to deal with the directions. So let's see. FABX is going to be 130 cosine. And since it's an equilateral triangle, do we remember what the angle is? 60. So I'll get a number. And then FABY, 130 sine 60. You guys are going to do these better than me. I got 65 and 113. Right? Newtons. And then FAC is just all in X, right? So what do I do with the X pieces? FAX is going to be 195. Did I add that right? Okay. And FAY is just going to be 113. And now that I know the X and Y pieces, what do I have to do? Well, I can't just add 195 to 113. They're components of a vector, aren't they? How do you find the magnitude of a vector if you know it's X and Y pieces? Pythagoras. Old Greek guy wore a toga. 95 plus 113 squared. And that better get me 224, because if it doesn't, I'm going to cry. 113. Yep. I got 225, because I think I rounded probably a little bit too hard. Okay. So we got that. Done. All right. What about B? F on B, right? Well, that's going to be the force on B because of A plus the force on B because of C. Magnitude-wise, what is the force on B because of A? It's already on the screen. What is it? It's 130. Did K change? Did the charges change? No. So and the distance didn't change. So this is 130 newtons, right? FBC is also 130 newtons for all the reasons we just described. But now we just got to we got to do the directions, right? So there's one of the forces on B, right? And what's the other force on B? It's going to be away, isn't it? Okay. So here we have to find X and Y components of both of them. Okay. So that means there's going to be like a part that points down and a part that points sideways that way. And there's a part that points up and another one that points sideways. I want to avoid some math, so I'm going to be clever. And I'm going to realize something. If those two vectors are both 130 and they both point at 60 degrees, did I get that angle right? I think I did. Okay. What can you tell me about the two y components, this one and this one?
Opposite signs.
They're opposite directions. One points up, one points down. But what are their lengths? They're both going to be calculated as 130 sine 60. So whatever that number is, right? I've got one that points up and one that points down. When I add them together, what am I going to get? So the y component is equal to 0 by symmetry. In physics, we mean, well, look, guys, everything's the same. Those are pointed the opposite direction. So they're just going to be 0. And we're not mathematicians, so we're not going to prove it. Right? Mathematician would calculate it all out and show that it all adds to 0 and blah, blah, blah. But we're not going to do that. Okay? And we're just arguing that because the angle's the same, the magnitude's the same, so therefore the y component magnitudes will be the same. And in our drawing, those are pointed in opposite directions. Two things, same length, opposite directions, the answer is 0. What's more, I only need to calculate one of these two components for the horizontal. FBX is going to be equal to 130 cosine 60 degrees. And then if I want the total, I just double this answer. Why double? Did I go too fast? Should I have done all the horrible math to prove that adding two things in the opposite direction are 0, and that adding two things in the same direction is just, and they're both the same? What's 1 plus 1? This is what I'm doing, right? I calculate 130 cosine 60, whatever that is. 65? Oh, we already found it, didn't we? Duh. Right? Okay. And then I just double it. Because the other one's going to be 65 also, isn't it? And they're both pointed in the negative direction, but the problem just asks for the magnitude, right? And so 2 times 65 is what? 130? Yep, that's what we got, right?
Is it just a coincidence that it's the same person you calculated?
I don't believe in coincidences. So let's see what happens when we do the force on C. Well, that's going to be C because of A and C because of B, right? Can I just say right now the numbers are the same? Magnitudes are the same, right? It's going to be 130 degrees. But what direction is the force on C because of A? It's to the left, okay? What direction is the force on C because of B? Kind of out in that direction, right? Okay. So I have this component right here, which I know is 130, and I have this component over here, which I need to find vector components for. Okay. So FCB x component is 130 cosine 60 degrees. FCB y component is 130 sine 60 degrees. We know these numbers, don't we? I'm running out of room. 65 and 113. This is a positive, but the other one's a negative. So if I do FCX, I've got to take a negative 130 plus 65. Where'd that come from? That one right there is plus 65, isn't it? I calculated it down here. And this one's negative 130, right? Because it's pointing the other way. So that's what that is. What is this? 100 and, no. It's a 55? 75. Never guess, Mr. Balogh. You can't do arithmetic in your head. Oh, it's 65. Of course it is. I'm an idiot. I just did all that math right up there. I just multiplied 2 times 65. So of course, 130 divided by 2. So, oh my gosh. 65. And then what's FCY? Well, it's 113, right? And so now we do the square root of 113 squared plus 65 squared. And you got 130. So, coincidence? Sure. Actually not. I mean, it's not surprising. What's surprising is that the force on A is different, right, than the other two. That to me is like, why is that? And I could think about it for a while and come up with a justification. It's not important to us right now. What it comes down to is on A, the vectors are like kind of working together, right? They're both pulling into the first quadrant. So naturally, I expect that force to be bigger than this force, which has vectors in opposition to each other, like kind of one's going up, one's going down, but they're both going to the left. This one's kind of surprising that it's the same as this, although maybe not that surprising because we still have this opposition coming right here. So it all checks with sort of how I expect vectors to go. But let's do a meta question here, okay? Will you have a problem on the exam that is this difficult?
Yes.
No.
Not to this degree.
Not to this degree, right? On the exam, will you have to find components of vectors? Yes, you can expect that. We've been doing that the whole time, right? Am I going to ask you to find it on all 3 of the charges? No. Those of you who had me before, what would I have done? Pick one. I wouldn't make you pick one. I'd pick one, right? Okay? And then I'd say, find the force on charge A, right? Okay? And you would just have to do that one. So you're still showing me that you know how to work with vectors, deal with the forces, apply Coulomb's law, but it's not, because the rest, the blue and the green were just the same thing, just more practice, right? So this is why I say homework problems are often harder than the ones I put on the exam, right? Some of you were like, no, it's the same difficulty, Mr. Balogh. I'm like, okay, yeah, same difficulty level, but maybe not the same time investment, right? Because a lot of homework problems are multiple parts that you're having to work through, and I'm like just asking for one part on the exam. Do you think you might see a triangle on the exam? How many times have we put charges in a triangle? What about a square? What about a rectangle? Right? These are all shapes that either been in your homework or I did in class or something like that. So we will not put them in an obtuse parallelogram or something like that. Well, I don't even know what that is. It probably doesn't even exist. But good question. Good question. Does anybody even remember this stuff? Does it feel like it was a long time ago, or kind of does, doesn't it? It was only 3 weeks ago. The real miracle is that when I was sitting in your seat, I was convinced there would be no way I could ever stand up in front of a class. And I wanted to be a teacher, right? I was convinced there's no way I would ever get to the point where I could waltz into a class and do a problem like this, cold, just being asked, and work through it and get it right. Didn't even clock that was a possibility. It's taken 24 years to get to that point, but... Other questions? Could you check right now? Somebody else complained about that right before class, and so I forced it. Apparently copy paste is not happy in Canvas anymore, and so I forced an upload of the image to the server to then give to you guys. Did it pop up this time? Yeah. My apologies. As soon as something like that happens, just don't assume it's you. Blame me. I can take it. I'm good, right? So just say, Mr. Balogh, something's wrong here. If you want to be nice, say, Mr. Balogh, Canvas is screwing up, which in this case it was, right? But you can also, Mr. Balogh, you made a mistake, right? You said this, but now this is on the homework. Can you please fix it? Somebody emailed me, and they were so nice. They were so lovely. They're like, Mr. Balogh, I've been trying this problem. I can't figure it out, and here's my work. Well, it turned out that it was a problem I told you didn't have to worry about. It was one of the Kirchhoff laws problems, right? It's like, oh, I'm so sorry, right? Don't. if you think there's a mistake, just ask me, right? If there's not a mistake, if it's a legit problem and I expect you to know how to do it, I'll just let you know, right? But that's much better. I would rather that happen than you spend 45 minutes arguing with ChatGPT over how to do the problem only to find out. I'll just say, oh, well, you don't have to worry about that. I would love to be able to roll out a perfect class for you. That hasn't happened in 24 years. Not once. Yeah.
Rule?
The what rule?
The loop rule?
Oh, for Kirchhoff's laws? Ask me later, because I don't want to waste time in here on that.
No,
Don't have to worry about it. Not going to ask you about it on an exam. I'm not even sure it's in the MCAT anymore. I'd have to double check that. It's been, last time I looked at the MCAT was over the pandemic. So. Can I do a question on capacitors?
I have one, but like,
Do you want me to make one up?
yeah.
What kind of question on capacitors? Just anything.
Capacitors is where the rule is basically the opposite.
Oh yeah. So on this topics list, just to make sure that you understand when I say capacitor, okay, I do not mean circuit reduction with capacitors. Your capacitor question is going to be about a capacitor. It's not going to be about a combination of capacitors. If I was going to give you, like, here's some parallel and series capacitors, find the equivalent capacitance, I would have said that, right? I would have said capacitor, series, and parallel, or something like that, right? So what could I possibly ask about capacitors that's like a calculation type question? Because I think this is the question that Yvette's asking.
Formula, basically.
Yeah, what do we know? What are all the possible like things we could know about a capacitor mathematically?
For parallel.
Not, but so I just told you there's no parallel in series
No,
on the exam.
For a parallel plate.
Oh, yes, for a parallel plate capacitor, because that's the only one you need to worry about.
So area divided by distance.
Oh, so the capacitance could be epsilon naught A over D, right? For finding the actual capacitance of the capacitor. Okay, what else? This is my way of asking, what have you put on your cheat sheet so far? Half of you are looking at me like, I haven't done that yet, Mr. Bailey. Yeah, that happens tomorrow. Great, as long as it happens before Thursday. Did I get that one right? This is Mr. Balogh trying to remember equations now. And that's dangerous territory. Why do you think I give you guys cheat sheets? Yeah, I always wanted one on my tests. And I only got them part of the time. So I want you guys to have what I didn't. There's others. Trying to remember them. The energy stored in a capacitor is 1/2, was it CV squared?
Yeah.
If you're in if people are expecting expertise of you, you should probably make sure that you know what you're doing. Yes, 1/2 CV squared. Your book also did 1/2 Q V. I think they use lowercase q's.
Yeah, they use.
And 1/2 Q squared over C. So, but that's like all I've got in my notes. So what could I ask you to do? With like the entire problem space, if using a mathematical term, that I could ask about these equations right here. Could I ask you to calculate the energy on a capacitor?
Yeah.
Sure. Could I ask you to find the voltage on a capacitor if you know its charge and capacitance? Sure. Could I ask you to calculate the capacitance given the area or the separation distance? Yeah, as long as I give you epsilon naught, right? Which I would. Variations on a theme of like that answer, right? Like I guess if I wanted to really be mean, I could ask you to have to put two of these equations together to find something. But I don't think capacitors really need to be that hard, because they're not. They're just capacitors. So, did I answer your question, Yvette? Yeah. I mean, the rest of it is just we can make up numbers. Like what's the charge on a capacitor if its voltage is 10 and its capacitance is 2? 20. Right? Adding numbers to it doesn't make it any easier or harder. It's just putting labels in. So, guess I could make it harder by asking you to solve for the voltage.
Are significant figures.
I mean, I don't care. Am I allowed to say things like that? I don't care. I probably should, but I don't. To the point where if you're off by 1 or 2, I don't care. Like it doesn't even register that you've got more sig figs than the problem's supposed to have. If you've put down 8 digits from your calculator, I'm gonna call you on it. Probably give you a -1, because in essence, if you start with 3 sig figs and you end up with 8, somehow you've increased precision by doing math, which is never true. So yeah, I kind of expect you to be in the ballpark, but not like. Shouldn't say things like this on YouTube. I know you've been hurt by chemistry teachers when it comes to sig figs, right? And chemistry has a really, really good reason for using significant digits, because the difference in significant digits can be the thing blowing up on you in your face. So it's good reason. But in physics, engineers, yeah, they get bent out of shape when it comes to sig figs, like the chemists. But physicists have the option. We don't do anything real. Nobody dies if we do our math wrong. We might yell at each other. Nobody dies. Did I answer your question? How you feeling about this stuff? Like compared to 2A, where's the difficulty level? Higher, lower, same? You're kind of all jaded. Mr. Bailey, we know physics. Just give us the exam. Get it over with. Remember, it's this unit and the next unit that are the hard ones. The other 2 have physics in them. It's not like it's a walk in the park, but like compared to this, like, yeah, there's no vectors in the last 2 units. There's kind of, we hide one in one spot, but like it's hiding. not really doing anything. So, yeah.
I was confused on question 4 of chapter 20 homework. For me, I didn't understand that the length of the wire was the length of the rectangular pieces it's talking about.
This is a bad graph. Why is this a bad graph? Gotcha. I know. I see it all the time. But I'm just going to say, shame on you if you haven't started yet. Right? You really needed to have started last week just to give your brain time. Right? So, I will never say I told you so. But I'll just say ahead of time, shame on you. All right. So, was 4 you said? Oh, yeah. You know, this one has given students trouble in the past, and maybe it comes down to visualization. Okay, so give me a moment while I fight with the computer. Is it really a computer? Are iPads really computers?
Like if it was 2 plates with space in between them.
Well, okay, so it's not a capacitor, right? It's a resistor. And so they're asking us to play around with this relationship right here. And the way that I know that is they keep giving me lengths of things. And from those lengths, I can find areas. But what I've noticed in the past is students sort of have trouble with like this. How is this different than this from this, right? And so a battery pushes charge around, right? So positive charges come out. So that means these positive charges would flow into this face through the bulk and come out the back face. So the current in this first example over here, the direction that the current is flowing is this way, right? So in this equation over here, for this first case, okay, and rho is just a number. They gave us a number, right? 1.5 times 10 minus 2. What's the length that this current is going through? Is it L naught, is it 2L naught, or is it 4L naught?
4L.
The length it goes through is 4L naught. It has to pass through the entire 4L naught. Okay? But what's the area? And in this case, it's going to be the area of this face, right? This is the cross-sectional area. And like this is the length, right? So what's the cross-sectional area? 2L naught times L naught, isn't it? Okay. And so you can go calculate that number. It'll turn out to be something, whatever it is. Okay. All right. What about this one right here? It's the same equation, but can you see like that the current's flowing out, going down into the top and coming out of the bottom like that? So what is the length that current is flowing through? It's just L naught. The length, it just goes through the thickness from top to bottom. Okay? And then what area is it going through? Like what's the length of this side and what's the length of this side? It's 4L naught times 2L naught, isn't it?
So it doesn't want length times width times height.
No, that would be the volume. Right? It's cross-sectional area. Right? So in the first one, this is the cross-sectional area it's going through. Oops. This is the cross-sectional area it's going through. In the second one, this is the cross-sectional area it's going through, right? In the third one, which face would I shade for its cross-sectional area? Like this front thing, oh, different color, Mr. Balogh. It would be this front thing right here, right?
So when it's asking for capital L, it's not asking for, I don't know why I thought like follow the wire.
Like, I mean, you kind of have to follow the wire.
No, but the other way. I mean,
Oh.
like the three-dimensional.
Yeah, not. I mean, it is 3D, but really in the end, all it depends is distance through and cross-sectional area of that path. So what would it be for this third one? What's our length?
2L.
It's 2L naught, and what's our area?
4L.
And then let's see, that's part A. Part B, and then the current, right? So once you know the resistance, how do you find the current? Meditate on it. If you ask me a question during the exam and I just look at you and say, shall we meditate together? That's what I'm trying to tell you. Isn't it frustrating when the teacher just like answers the question, like just waltzes in, and you've spent who knows how many minutes, hours, lifetimes on the problem, and the teacher's like, oh yeah, oh, yeah. So annoying, isn't it? So annoying. Again, what allows me to do that?
25 years.
Right, yeah. Having seen this problem for the last, 7 years that I've used this problem? Revamped the homework about pre-pandemic times.
Thank goodness that's over.
Equations? You mean like things that I would put on the cheat sheet? Yeah. Oh my gosh. Do you have all day?
Like all the laws, right?
Yeah, so the only reason I don't like answering that question is because I'll start putting them all on the screen or the board, and then I'll invariably not put one down, and then students will be mad at me after the exam. Well, Mr. Balogh, you didn't put it on the list. Here's the problem. The equations I need and the equations that you need are two very different things, right? Because we're operating on different levels. Like, I probably wouldn't put Q equals CV down on my cheat sheet, because that one has been, it might as well be tattooed on my eyelids, right? Because I've used it so often. But what does have to go on my cheat sheet is a really big box that says parallel and series resistors, parallel and series capacitors. I guarantee, I've been doing physics for almost 30 years. I still can't get that straight. Do you add the inverses, or do you just add them together in series and parallel? I don't know. Do you add resistors in series? Do you add them together? Is that the rule? Like, honestly, I don't know. Like, I have to look at my notes. Did I get that right? When you add resistors in series,
Yeah, 'cause there's
well, that doesn't mean anything in my brain. Yes. Okay, in series, you just add the resistances together. The only reason I got that correct is because I guessed, and I had a 50-50 chance. That's the only reason. So, like, for me, that's a big deal for any cheat sheet I have, right? But the capacitor equations, no, I can like derive those from scratch. I don't need those. So, I'd love to be able to answer your question, right? What's a resource? Where can you go to see what the textbook author thinks are like the key equations or ideas in a chapter?
Back in the chapter.
Yeah. Okay. So if we go to the modules, right? You come down here, chapter 20, learning resources, okay? And just pick any one of the textbook links. It doesn't matter, okay? It'll take you to the textbook eventually. Okay? And if I go down, or I just look in the table of contents, okay, and get here, internal resistance, not what I wanted. Keep going, keep going, keep going. Where is it? There's a summary down here somewhere. RC circuits. No, I don't want that either. Ah, here we go. Okay. So here is the concept summary, right? Right here. And I can see that they're giving me the current equation, Ohm's law, this resistor equation. All right, here's some equations that Mr. Balogh never talked about. Do you think you need them?
Yes.
Probably not. Is there something in the topics list that says resistance as a function of temperature? No. Don't need to worry about it. Okay. Have these come up? Yep. Okay. So, but what about this? Did we ever do like voltage as with sine? It almost looks like that's a vector, isn't it? Like a vector component? It's not. It's AC circuits. We'll get to it later. Okay. We didn't do RMS, right? But we did have these resistors in parallels and series, right? Did we ever do anything with exponentials? No. It's coming up. It's coming. We'll circle back to it. Okay. So, like, this is a good, like, template for what the major port. Now, did that cover everything we did with all those circuits? No, because with these two equations, there's a lot of concept that has to go along with it to apply them correctly, doesn't it? Right? So there's that. The other resource you've got is that if you go to, you scroll down on one of these learning resource chapters and you go to Student Study Guide. Okay. The Student Study Guide gives a glossary, so terms that are probably new to somebody that's studying this, right? Conventional current, series wiring, right? That kind of stuff, right? It then gives a list of the equations that are in the chapter. You can see there's a few more here than were listed in that summary in the book, okay? They give some equations, series, parallel. Again, we didn't do RC circuits or Kirchhoff's rules, so you don't have to do that, right? And then there are like a little bit more detail on these things, okay? Electrical power, right? There's all the power equations. We didn't do alternating current. We're going to do that later after we do magnetic fields, okay? Series wiring, we did that. So there's a lot more information here. They do some examples, okay? They even have down at the bottom, where are they? Okay, practice problems, right? With the worked solution. So, oh my gosh, what the heck is going on here, right? This is great practice, right? You could look at this, quiz each other on it, like which of these are in series, which of these are in parallel, and then how could you check yourself? Work solution is right there, right? So have the control to try the problem first, and then if you get stuck or you're not sure of your answer, hit the work solution, compare and contrast, right? So there's lots of different ways to go about like figuring out which equations we need and all that kind of stuff. Grace, did I kind of answer your question? It's a really good question, but one that I don't like answering. I don't like just saying, well, here's all the equations you need. Because invariably I'll either put too many, too few, somebody will get mad. This is why I don't give you an equation sheet, right? I don't do a cheat sheet for you. Because again, I want it to be yours, something that you know how to reference. Other questions? Or should I say the last question, because we only got 5 minutes. When's homework due? Tomorrow, which is why more than half of you have not started. I used to think that I should have had homework due every day, right? 1 or 2 problems a day. You guys have to do it yourselves. You gotta learn how to Work it yourselves. And like you, I would hold off on homework assignments until they were due. And it only took me until halfway through my junior year to realize that didn't work anymore. You're not doing it wrong. In fact, the very fact that you're here means you're just doing it right. I'll see you on Thursday.